Exponent functions, finding the derivatives of exponential functions. In this lesson, the letter E represents a number, so it's e to an exponent, and typically this is used for growth and decay problems. So when you take the derivative of e to the x, you leave the base e and you take the derivative of the exponent. Now the derivative of x in this case is 1, so we don't write the 1 at the end, and you'll see how this works as we go through a few examples. I have 3 examples for you in this lesson. So you can also see down below e to the g of x, and so when you're taking the derivative of this, you leave e to the g of x, and you take the derivative of the exponent, which would be g prime of x. And in this lesson, you'll see that you'll have to use the product rule, the chain rule, and sometimes even the quotient rule. So for example 1, if I need to take the derivative of y, we leave e to the 3x squared and take the derivative of the exponent, which is 6x. And so what I'll do is I'll just bring 6x to the front, and then that's it. You've taken the derivative of it. So when you're taking the derivative of these type of questions, they actually sometimes end up being bigger than the question itself. In example 2, I've changed tan to the root x to tan x to the 1/2, and I have to take the product rule here. So the product rule, I leave the first term, take the derivative of tan x to the 1/2, which is secant squared x to the 1/2, times the derivative of what's inside. So I'm using the chain rule, and the derivative of x to the 1/2 is 1/2 x to the negative 1/2 plus e to the negative 3x, and I take the derivative of the exponent, which is negative 3, and then I leave the second term. So in this question, in this expression, I'm just going to simplify it a little bit. You can see that on the right hand side I have negative 3, and I'll bring that to the front. And I also have x to the negative 1/2, which that term there I'm going to bring into the denominator. So since the left hand side is all multiplication, I can bring the 1/2 x to the negative 1/2 into the denominator, and I've changed it in the denominator to 2 root x. So just take a look at how I've simplified it, and there you have it. There's the derivative. In the next example, I have to take the derivative of y with respect to x, and on both sides of this equation I'll be using the product rule. So on the left hand side, using the product rule, I leave e to the x. The derivative of cosine is negative sine y dy dx. The derivative of e to the x is e to the x, and we would multiply it by 1, but we don't write that because the derivative of x is just 1. We just write e to the x cosine y. And on the right hand side, leave the first term, take the derivative of e to the y dy dx. Derivative of x is 1, e to the y. So since I'm solving for dy dx, I'll have to have my dy dx terms together, and I'm going to have those on the left hand side, and I'll bring the e to the x cosine y over to the right hand side of the equation. And remember, when you're shifting from left side to right side, you need to change the sign. And I've done that here. When you cross over the equal sign, change the sign. I'll factor out the dy dx and then divide. So it does end up being this long quotient, but that's the derivative of it.